Okay. I think it's time. Let me know if the sound is okay. if you can hear my voice. Well, hopefully everything is okay. All right. Thank you. So this is another weekly live tutorial for Houdini. The topic for today is so this is Junichiro Horikawa, and this is a weekly tutorial live for Houdini. And the topic for today is to create a kind of a procedural modeling setup to create this spiral carving model, which looks like this currently right now playing inside Houdini. So basically what I'm going to do is to prepare a 2D curve which looks like just a simple pattern like these, and continuously creating a connection between these closed curve by first of all trying to open it with some gaps, and recursively continue connecting it as a spiral curve, which in the end looks like these in a mesh. Then going to project this base mesh onto a sphere and use it to create a carved like surface in the end, which looks like so. This is the mapped surface onto a sphere, and by using some calculations, algorithms, I'm going to create some carving effect onto that surface like this, using an information gathered on this feedback loop. Then create a surface like this, and you could control how much the size of the surface is on top of the sphere by changing some of those values right here, which currently is controlled with a frame rate as well as some parameters you can control with. You can also change the layers as well, and so on. Now I'm going to show you how to actually do this in Houdini from scratch. So, and this process could be used for any kind of closed curve. Could be a circle like this. Circle could be a spiral, just a simple spiral curve, spiral circle-y curve, or it could also be something like a star shape like this. Could also work like this. Okay, so could be pretty interesting. And if I manually try to change these pattern, for example, if I set the shape scale to smallest value, you could control how much of the shape is going to place on top of the sphere. It's like that. And you can also control the mapping of the inner patterns, like if you have more patterns on the outline, or if you have more patterns on the center. You can also control how much layers you could have, how much height you could have, and so on. So that's pretty much it. Hey, thank you. Thanks for Japan. Thanks from Japan. Okay, so let's try doing this. And hope the reason why I created this pattern is something I wanted to create something I could 3D print myself as maybe a gift, maybe. So that's just my inspiration. Okay, so let's try to do this from scratch, and if you got any questions during the live stream, let me know. I'll try to answer it as much as possible. The the setup possibly should be simple enough or straightforward enough. Okay. So first thing first, let's start by creating a 2D pattern like heart shape or circle shape, anything you like. Maybe not too complex. It's preferable that you choose the curve, the pattern, which is simple enough so that you could create a spiral-like shape. Fit image, full screen video. Is it not fit? Let me see. Maybe the aspect ratio is different. Or is it too blurred or anything? Let me just check. Let me check how it looks like. Maybe that's because I'm doing the live stream on Mac directly, which has a different ratio compared to 16:9. So that might be the reason. And currently it is full screen in my Macintosh, but probably might not be in live stream, which I don't know how to fix it. Well, at least I could just try to make it full screen like that. Okay, well, this is best that I could do, I guess. Sorry for that. Okay, so let's do this. So first thing first, what I'm gonna do is to try to create some basic shape, and I will try to create a heart shape as a starter, since it is kind of complex enough for testing. A bit complex than the circle, so could be could be a good start for testing, I think. And there is some several equations in order to draw heart by equations, which I have searched on Wolfram Math World. And there are a bunch of curves which looks like a heart shape, and I think I like this pattern, which is this one. So let's try to first of all create this heart shape using an equation, shall we? So I'll put this aside here, make the window size like this, and let's start by creating a 2D curve. I'll start by creating a circle first as a base, and let's place this circle on XZ plane to a ground plane. Also, let's make it as an open arc to make it as a curve, polyline curve. Let's have enough points to have a dense, smoothed image or curve. Let's also save this to today's folder. Okay, now let's have a point triangle so that I could control each point positions based on these equations. So let's try to copy these equations as a code. So float x is 16 by power sine of, this is t and 3. Okay, so this t should be in an angle between 0 to 360 degrees, I think. So let's create the t value, which I'll just divide the point number by the number of points minus 1.0, because the end point and the starting point is on the same positions for open arc, and multiply by pi multiply by 2, so that I am multiplying each point number, normalize each point number value, and multiply by 360 degrees in degrees. If it's in radians, it's 2 multiplied by pi. So that I have each point associated with each angle from 0 to 360 degrees. Now the y value is 13 multiplied by cosine t minus 5 multiplied by cosine 2 multiplied by t minus 2 multiplied by cosine 3 multiplied by t minus cosine multiplied by 4 multiplied by t. Okay. So let's apply this position to the current position. Just update the current position with this x and y. X goes to x, y goes to z coordinates, because we're working on the xz coordinate. Okay, so where did it go? Okay, now we have it. So yeah, looks like the same heart. Okay, good. So first of all, we have a base heart shape. Now next, in order to make this heart shape spirally continuous as a one stroke polycurve, what I would do is to create some gaps between the starting point and an end point, so that I could continue adding a new heart on the next layer. Which, what I mean is to create a heart something like this, so that on the next step you could zoom this current heart shape to connect with the previous one. Continue doing this until you're satisfied to make a continuous spiral heart based curve. Okay, so that's what I'm gonna do. So to do that, I am going to use another point wrangle, I guess. So let's create another point wrangle. Let's call this curve offset, or call curve opener. Okay, the first of all, it's a good idea to have a normalized point number again. So I will just copy this part where you are getting a normalized value for the point number. So you're just converting the point number from 0 to 1 as a float number. Okay, and what I'm gonna do is to try to scale each point from the center of the curve, the base pattern, and scale it from 1 to more than one value. So the starting point should not be scaled, so the scale value should be 1. The end point, in the end, it should be scaled to something bigger, maybe 2 or 3 or 4, a little bit less, so on. And let's try doing that by let's try creating a scaling value by remapping this t, which is in between 0 to 1, so we can use fit 0, 1, and the first value should be 1. The first point should not be scaled, and the last point should be scaled more than 1 with some additional scaling value. Could be 0.1, could be 0.2, could be 3, 4, and so on. And you just need to scale each point with this scaling. Now if I increase this, you see that the starting point of this heart shape is not moving, but gradually all the other points is scaling based on this linear mapping. Okay, just like that. Okay, so that's good. Now, so this is the base curve setup for 2D. Now what I want to do next is to continuously scale each pattern so that the previous curve should be scaled so that the starting point will be touching the end point of the previous curve, and use that scaled curve as a next iteration and next curve for the next step in the loop. So what I want to do is to create a loop so that I could have as much as I want to continuously connect the scaled heart as a one stroke curve. So let's do that. I'm going to have this in the network box, and let's have a for each number so that I can decide how many layers that I want. Okay, so there are some setups that I want to set for this for each loop, because I want to look at the previous curve, how much of the previous curve has been scaled in order to create a new layer. Let me just delete this. So let's say you have the first curve like this. Now in the next loop, what you want to do is to move this point to this point, or scale this point to the point above, so that it will be scaled like this. And on the next loop, you should again do the same scale, but from this point to this point, which should have a different value for scaling. So each time you go to a new layer, you need to recalculate how much you need to scale in order to touch the previous starting point to the previous end point. Okay, so to do that, you do need to make the loop feedback loop, and you can do that by making the method to fetch feedback so that you can get the newest data. Okay, and for each end, you can just set as much each iteration as it is, I think. I mean, you could also do feedback each iterations, but I would just go with the merge each iterations, because you just need the newest curve, and that's the only info you need. Okay, so let's do that. Now, let's also set a group info to this curve, because later I'm also going to create a surface inside this loop as well. So I'm going to name as curve as a primitive group. Okay. Now, so first thing that I would like to do is to try to scale the whole curve so that the starting point of this curve will touch to the end point of this curve, this hard curve. So let's try doing that. I'm going to try to use point wrangle. Let's name this scale. And first of all, I want to get the point position of the first point and get the end point position of this curve. And if I check the point number, let's limit the iterations to 1 for now. If I check the point number, see that the first point is right here, end point is right here, so I can just say the position 1, the first point is coming from the first input, 0. The endpoint is endpoint 0, which is the number of points, minus 1, which will be the endpoint number. And I should not use float. Okay. So now I have 2 point positions, this point and this point. So in order to make this point goes to this point by scaling, you just need to calculate the lengths divisions between the pos2 divided by pos1. So this will be the scale in order to make this point to go to this point by scaling from the center point position. Let's try doing that by just multiplying the current point position by scale. Okay, so hopefully it has been moved, and let's check it out by going outside of the loop and increase the number of iterations, and as you can see, it's been succeeded. Okay, and you are missing the initial curve, so you also have to merge the initial curve in the end to have the complete layers. Now it might be okay if you're just working on the 2D plane, but in the end I would like to use this as a guide reference for a carving the mesh. So to do that, what I found is better is to have a surface in between the next layers, next curve, meaning I would need to have a layer between this curve and this curve, I mean the surface between this curve and this curve, and have some divisions in between these curves in order to use them as a base for carving, which I mean by these carve. So in order to have this valley-like shape or carved-like shape on top of the surface, you need to have some resolutions, you need to have some splits, divisions on a surface, and that's what I'm going to try to make next. So we do have the current outline curve like these, but we don't have these inner edges information, so that's what I'm going to make next. Okay, so let's do that, and later we're going to map this on a 3D geometry. Okay, so in order to do that, what I would need to do is to first of all specify how many divisions you want for each surface in between the curve and the next curve, the scaled curve. So I'm going to have another for loop inside this loop to decide how many layers, how many divisions you want for a surface in between the original curve and the scaled curve. Okay, so I will first of all connect the, should I connect this one, or maybe I should connect this one, the original curve, into a for each loop, the new for each loop, And for the setup, I'm just okay with the fetch input and the merge count. You just need to change these numbers in order to specify how many layers you want. Let's go with 10 for now. Now I will use a point wrangle to have a kind of a tween curved in between the original curve and the target curve. So I need to have a tweened curve in between them. Okay, so as a target, I'm going to connect this to the second input, and let's call this tween curve. And in order to specify, in order to get the current iteration number for this for each loop, I'm going to connect this for each count to a third input. Okay, and let's get the iteration number from the detail first, from the third input, as well as the number of iterations, which is in this case 10. We have 10 iterations, but it's better to get it automatically. Now let's normalize this iterations value from 0 to 1. Currently it's just the integer value starting from 0, 1, 2, 3, 4, and so on. But it's easier to use when it's normalized, so let's call it t. So you can normalize it by dividing iteration number by number of iterations minus 1. Okay, so meaning if you have 10 iterations, the maximum number of iteration number here is 9 because it starts from 0. So you need to subtract the number of iterations by 1 so that you could divide 9 by 9 in the end to get the value 1. Okay, so now I got t. Now I can use this t value to tween between the source geometry, which is this one, to this target geometry. And each one has the same point number, 101, 101, so it's pretty easy to do that. So let's get the corresponding point number between the first one and the second one. Actually, the current point number is just at p. The target point positions is coming from second input at ptnum. Okay, and we have now the source positions and target positions, and we want to tween between this one and this one using t. So we could just use a function like lerp. So from pos1 to pos2, choose the appropriate positions by using t from 0 to 1. If it's 0, you'll choose source. If it's 1, you'll choose pos2. If it's 0.5, then it's the halves position between this one and this one. The average position between this one and this one. Okay, then update the position with this tweened position, or larped positions. And in the end, you'll be able to get this continuously layered curve, which is going to be used to create a surface. Okay, so now I have a bunch of curves between the source curve and the goal target curve. Let's create a skinned surface out of these curves by using skin. Okay, so this will be corresponding with the single carved surface, which is going to be projected onto a sphere. Okay, all right. And anything else? We could also have some additional information to the surface, such as putting some groups like surf Maybe I'll do the same for the point group as well. And as an additional informations, I think I would like to create which point is being located in where. For example, from this source to end, I would like to have the informations which point is belongs to which t value or tween value. If it's 0, or 1.0, or 0.5, and so on. And as an additional information, I also would like to have an information going from start point, which is here, and end point, which is here, by going around counterclockwise. You also want to need to have an information which positions it is being located for each point, which it corresponds with UV in the end. So let's have that information as well. And currently this curve, the original curve, does not have any positional information as an attribute on each point. It just has positions, but it doesn't have a parameter like U. So let's add that parameter, which can be brought into a surface as well. So I'm going to use resample as a starter, and I am not going to resample the curve itself, but I just want to output the curve U value to each point, which will create a normalized parameter value from 0 to 1 from start point to the end point, which is pretty handy in order to determine which point belongs to what part of the curve, which position of the curve. Oops. I have just deleted the scene tab. No, not this one. Viewers, scene view. And I think I also deleted the geometry network. Okay. So so this is good. Resample made you possible to get the curve view informations. And if I go back to a surface informations, and if I check the geometry spreadsheet, I can still see the curve view, which is supposed to go from left to right. Let's check that. I'm going to visualize the curve view as a text to see if it's really created. Okay, why am I not seeing anything? See, so this is curve view. So curve U. Okay. So if I look this curve carefully, so this part where the heart curve starts from 0 and it ends here somewhere, which is end at 1, think. Okay. So this seems to be preserved. Now I also would like to update this curve view based on which iterations you're on with the first loop. Meaning you have multiple loops being created for spiral curve. You want to know what I'm thinking is that you want to know in which steps or which iterations you're in for each spiral layer. Okay, so in order to be able to get that, I'm going to modify the current curve view by adding the current iterations. So meaning I'm going to update the current curve view by getting the current iterations value from the detail. So in the end, you'll be able to get value more than 1, but each value can have an information which layer you're in, as well as in which specific positions you're on top of the curve. Okay, and as an additional information, you also need the perpendicular positional informations, which goes from this point to this point. Okay, so you can apply that inside this tween curve, which you just need to have this t informations apply to this perpendicular directions. Let's call this curve V. Okay, and if I check it, so you have curve V from 0 to 1. And let's check it out by seeing the marker with the curve V. Curve V. Okay. So starts from 0 and at 1, just like that. So this is additional information which is handy, could be used for many purposes. Okay, so I think we are ready for leaving the loop, but what we need to be careful of for this setup, for this loop, is that in the end of the loop, if I make this output connected, if I make this output, if I make the output of this node connected to the end, this is a feedback loop, so the same thing's coming from the input again on the next iterations, and the next iterations only relies on the curve information, not on the surface information. So what we need to do is to just get the curve informations from the first input, the previous input, and use only that to process the next step. Okay, so this is necessary, I think. Now, and you also need to output the scaled curve to the input, the output, so that it can be used for the next iterations. So merge the scaled curve to merge the scaled curve and the surface and output it. Okay, and now should be able to get a list of layers 1, 2, 3, 4, 5 layers, and you are also getting a carve information as well, I think. So let's split this into carve and surface to see the differences. So from the left hand side of the split with the term curve group, you get a connected spiral curve, and on the right hand side you get a surface. Okay, and actually I don't think I'm going to use this curve in the end, just used as a reference inside here, but everything else that I'm going to do next as a next step is relying on this surface. So pretty much I think I can ignore this curve from now on, but maybe it might be useful in some case, so I'll just left here. Okay, so this is another step. You have just created a layered spiral surface. Okay, I'll make the network box like this. Alright, so we're close to the end, and maybe not. What we want to do next is to think about how we can map this 2D surface on top of a spherical geometry. So let's say we have a sphere like this, which is currently really small. Let's set the size of each geometry the same, around the same size. So I'll change this heart size a little bit smaller so that it can correspond with the sphere. Currently it's because it's pretty big in terms of the unit. I'll try to scale this output geometry, the heart shape, by using match size to match with the spherical geometrical size. Okay, so for now it looks fine. I mean, now let's think about how we can map this geometry, this hard geometry surface on top of a sphere. Okay, now before getting into a mapping, what I would like to do for now is to, if I look carefully at the geometry, you do see some hole on the center. So it depends on the preference, but I would like to fill this hole as a final shape. So before mapping this surface on top of a sphere, I'm going to try to close this, fill the gap, fill the hole with some process. Okay, as a preparation. Okay, so to do that, there are many ways to do that. I mean, the easiest way could be polyfill, but I don't think it's gonna work with this pattern because it's not fused yet. But I don't want to fuse this at this point, so for several reasons I'm not going to use this. Instead I'm going to use a wait a minute, but I might need to use fuse after all. Yeah, in order to make this part closed, I think I do need to use a fuse node. But just be careful that if the snap distance is too big, you're going to have some issues on the connections because some of the points are too close to each other. So this is before and after. You see some big differences between before and after. So in order to avoid moving those points drastically, let's increase the snap distance to small enough values. And because of that, you might want to do it before changing the match size, maybe. Okay, and make sure this does not change drastically, change the geometry drastically. Okay, looks good. And now use a divide node, which is right here, and use the option inside the divide node called remove shared edges, which will make the outline of this whole surface and the inner hole split it. And I just want to get the inner hole shape right here on the center, small heart shape. So let's just get that by sorting the primitive by the area, which in this case you have only, oh, it seems to have, you have several curves. That is because these are curves. These area equals to 0 are curves, and these primitives which has areas are the primitives which has faces. So I just want to get this one, the second largest a primitive which has areas. So what I'm gonna do, I'm going to sort by area and make it reversed so that the first one will be the biggest area Okay, and I just need a second one, which should be the whole shape. So let's just get that one. Delete non-selected. Okay, so now I can get the center heart shape as a whole, which is which the direction of the surface is reversed because of its hole, so in the end I'm going to make it reversed so that the normal direction will be the same. Okay, and finally this is not ideal, for projecting on top of a sphere because it doesn't have any inner edges. So let's also create an inner edge by doing remesh. And the value for the target size depends on the size of the inner hole, so it's a bit hard to estimate, but should be similar to the edge lengths of the outline, somewhere around here. Let's also increase the iterations, maybe somewhere around here. Okay, looks good. Now that we have a inner surface, let's also put this inside the same group called surface as other surfaces, and finally merge it with the layer surfaces. Okay, not this one, but this one. Alright, just like that. Now one thing to note is that the inner heart shape does not have any informations like curve U or curve V, so there might going to be some problems for that, but for now it's okay. Now after we have this merge, let's again fuse it. Okay, and probably I should do the match size after I've done all the fusing thing, or maybe not. If I do this, I need to change the remesh size, so maybe after all should be better using match size here. And in the end I'm going to fuse this again. Okay, so changing the number of points a little bit, fusing the number of points a little bit. Okay. Okay, so far now that we have prepared a surface for a mapping, it's time to actually implement a mapping system from 2D to 3D spherical shape. Now there are a bunch of ways to do that. The most obvious easy way is to just use orthographic projections, which is okay if the size of the pattern is small enough. But if you want to cover more than half of the size of the sphere, then that's not going to work. So what I'm going to use for this setup is a conformal mapping projection. Conformal mapping which could easily be done by using a function or node called UV flatten, which is based on the conformal mapping algorithm, either spectrum or angle based. So first thing first, well, same as UV mapping, just a way to make how you create a UV map for projection. So let's create the sphere as a target shape, which is this one, somewhere around here. Okay, and let's make this high res enough for final shape. I'm gonna make it 251, 251. The reason why I make a odd number is to have a line on the 0 coordinate for z. If I make the column or row to even number, you have a face on the middle, but I wanted to have an edge on the 0 of the z equal to 0. So that's why I made it even number, a odd number. Okay, but maybe that doesn't really matter. Yeah, it doesn't really matter after all in the end. So you can just decide which one you want. I mean, let's try with the even number if it's gonna work. Okay, so first thing you want to do is to UV map this sphere so that I can map the 2D image onto this sphere. If I just directly use the UV flatten as is, doesn't create a nice UV. You see some mirrored UV like this. That is because the sphere is a closed surface. In order to make this UV flatten a conformal mapping work, you need to make sure that you have some breaking seam edges or some open holes somewhere on this sphere. You need to have some sorts of open edge or open surface somewhere. What I'm going to do is to make some small hole on the bottom so that I'll be able to use a conformal map to create a map, UV map using this UV flatten. Okay, so first thing first, I'm going to create a normal vectors on each point and use a clip goes to a y positive directions and try to make a small hole on the bottom, something like that. Small enough hole. I mean, this is where you could, this shows the maximum area you can map your pattern on top of a sphere. So with this hole created, you can at least map your pattern until somewhere around here, somewhere around this edge. If you want to go close to the end, you can make this like 49 or something like that. But things to be careful is that more you go, more less hole you have, more surface you have on the bottom, more distortion you're going to get on the outside, somewhere around here. So if you would rather have less distortion on your pattern, you better keep the hole a little bit bigger. If you are okay with the distortions, you can make sure you can make the hole smaller, and so on. I'll try with 49. Okay, so you have a small hole like this, and with this hole, the UV flatten will create a UV map like this. Okay, so you have, so in the, I guess this shows that you have less distortions on the area where you have a hole, high distortions on the certain centers. Okay, meaning small change on the scale of your pattern will make a drastic change, especially on the edges, especially on the border edges. Okay, so there are differences between the center area and the edge area in terms of the scale of the pattern mapped. Okay, so that's how conformal mapping works. If you change to angle base, it's pretty much the same results. So whichever you like. Okay, so now that I have a base, it's time creating a flat base for a mapping. Flat shape as a base mapping. So what I'm just going to do is to make this 3D spherical shape. Just get the UV data from that each point and use it to create a disk on top of the XZ plane. Okay, so I'm gonna create a disk from UV. Okay, and should I use point wrangle? Yeah, I guess so, because I'm going to move the points. So let's get the UV informations, which is stored in the vertex. So I need to get the vertex numbers from the point, which you can do that by using point vertex. And the UV can be retrieved by using vertex function or UV at VT. Okay. And what I'm going to do is to just use this UV as a point positions. UV.x goes to x, UV.y goes to z. Okay, and this is the result. Right? And it's flipped. The normal direction is flipped, so I'm going to subtract UVX by 1 so that it will be flipped again. And also I kind of want to place this UV map on the center of the surface. I mean the world position. And since this UV is mapped in between 0 to 1, you can just subtract it by 0.5 for x and z to move it in the middle. Yeah. And let's also fix the normal. I mean, in this case, the normal direction is just up direction, I guess. Okay. And the 2D map looks like this. So what I'm going to do is to place a heart shape on top of this disk and use both UV, the UV from this disk and the UV from this sphere, to map from the surface, the flat surface, to a 3D surface. Okay, that's what I want to do here. Now let's try doing that. So in order to have a heart shape inside this disk shape, I'll do another match size for the heart shape to fit inside the disk first. Okay, well, it's still outside the disk, so as an additional operations you need a transform node to scale this a little bit smaller so that it will fit inside within the disk. And if you like, you could also change the offset between the x and z position. For now, let's just try to change the scale like this. Okay. And now that we have a scaled heart geometry inside the disk, we are ready to map this into a 3D sphere. So let's do that. So let's call this sphere mapping. We have a guide from the disk as a UV. We have a guide from the target sphere, which we're going to use a UV. Okay. So first of all, what I would like to do is to get the corresponding UV value for each point of this surface from the second input with this disk coming from this disk using a UV sample functions. So UV is equal to UV sample. Want to get the UV as a result. Want to use the P as a sampling value, current point position as a sampling value. Okay, now that I have a UV, I want to use that value to get the point positions from this sphere. Okay, so using the same functions, UV sample, but in this time I'm going to get the final position. From the third input, I want to get the point positions using UV as a sampling value, current, using the retrieved UV as a sampling value. And finally, update your heart positions. And now the sphere, the heart shape has been mapped onto a sphere. And as you can see, this is pretty big, covering pretty big size in the sphere. So if you try to scale this down a little bit more, starting to see more like a heart-like shape. So even a small number of scaling will give you a good amount of sphere. That is because of the scale difference between the top part and the edge part. Small difference on this part will give you a drastic results, even if it is, even with the, so it's more of a logarithmic scale, this case. So that's one thing you need to be careful of. And it could go until somewhere, until you have a hole clipping the image. So maybe this is something around the maximum. And you are seeing another heart shape in the middle, which is kind of interesting to see. Okay, so you have like two hearts, one here, one on the center somewhere, yeah, somewhere here. Okay, so that's what you need to be careful of for now. Let's go with this value, 0.01. Okay, now that the surface has been mapped onto a surface, it's time we apply some carvings to the surface using a bunch of informations stored in the surface points, such as curve U, curve V, and so on. Okay, so let's do that. So this is a mapping. Right. Now, at this point, I probably don't need the curve informations anymore. So let's split the curve and surface, and just trying to use the surface instead of curve. Do we have the same things? Okay, we did have the same thing here. Hey, the curve could be used for something, but for now I'm not gonna use it. Instead, I'm just going to use a surface because it has all the information that I need right here. Okay, so let's think what we're gonna do with this. So let's see. I am going to use another point wrangle. Name as carving. And based on the value each point has, I'm going to try to move the point to a normal direction of the surface. Okay, currently the normal direction is not stored as an attribute, so let's have that. I'm going to bring the normal directions from the sphere when we are using a sphere mapping. So I'm going to retrieve the normal value as well from the sphere. Addition to the point position. Then copy that normal to a heart shape. Oops. Okay, now the normal has been transferred cleanly. Okay. And we're going to use that to offset the offset each point positions of this heart shape. Okay, so first thing first, let's think about what value to use. So let's go back to what's this? Let's think about what to do. So let's say that we have a layer like this for a heart, which looks like this. And what I want to have is a carved shape like this for each layer. And to do that, we need to define how much the point moves on each point on its layer to a normal direction or negative normal direction. Okay, so if you look from the section view, you want to have a curve like this. And probably where the curve is placed, you don't want to move anything. So you're moving 0 value for this direction. But on the center, you might want to have more offsets. And eventually create a sphere-like or curve, mountain-like curve like this. Maybe I'm drawing wrongly. What I meant is to originally the curve is placed as a flat shape, but just want to move each point so that it will create a curve. It will create a mountain-like curve like this. And for this reason, for this purpose, maybe I can use trigonometry like sine as an easy solution. So let's do that as a first step. So, and for the value that I'm going to use, that's a perpendicular value to a layer, which we have stored it as a curve v value. So I think we could use this curve v as a starting point for carving. So let's see. So curve v, let's try to convert this into an angle for trigonometry. So this is from 0 to 1, from one layer to another layer. So I'm going to multiply it by pi, 180 degrees, and then use sine, which will create a value in between 0 to 1. Okay, and now let's try to move the point to a normal minus normal directions by, okay, this is actually not an angle. Let's call this carval, and let's try to move the point position to a negative normal directions by carval. And now it's moving too much because we have to decide how much it should move as a maximum value. So let's also multiply the wave height. Curve height. Okay, which then you can decide how much curve you would want for each layers. And seems like it is working. Okay, now might be easier to see with the normal updated, so in the end let's update the normal. Okay, looks good. So, and one thing you could update is to define the height of the wave based on the size of the layer. you see if the width of the layer is small, and if you're using the same height, the carving height, it looks a bit too drastic compared to the outer shapes. So you might want to control the amount of height based on these width, I guess. And currently we do not have those width informations. That's one reason is because we haven't stored any informations like that, and another reason is because it's largely deforms based on the UV mapping. So the UV mapping part is kind of difficult to track. I mean, you need to recalculate the lengths when it's being mapped, but it is going to create some issues when using animations. So the best way is to try to calculate the lengths before mapping the surface and just forget about the layer width difference for a UV mapped result. But let's see what we got right after we do a layer creating, and just try to see the curve if it's visible enough to track the change of the width. Maybe it does have some drastic changes between the inner curve and the outer curve, so it might be a good idea to track these lengths after all. Okay, so how do we get, I mean, it kind of depends on where you are looking at. If you're looking at the center point, the starting point, the length difference, I mean, it's all being controlled by the scale, so maybe tracking the scale value itself might be a good idea, which means it's this value here. Okay, so let's see if we do see any difference for this SC. Just going to apply it as an attribute and see how different for each layers or each iterations. Let's see. So SC start with 1.6. Okay, so scale wise everything is the same, so you cannot really use the scale as measures. You do need to have some length differences, I guess. Okay. In that case, maybe I could just reference the perimeter of each curve, and that could be referenced maybe. It's not really a perpendicular directional size, but I guess you could still use that as a reference. So let's just get that information, shall we? And so to use that, which perimeter should I use? The first one or the second one for the surface? Let's just use the first one. So I'm going to measure the perimeter for the first curve, the curve, calculate the perimeter, and since after the skin the information is not going to be preserved, I think we need to get this information stored on the end, in the end, to the surface. So I'm going to transfer the attribute by maybe using attribute transfer. Connecting this here, and specifically just want to bring up the perimeter Right, perimeter and the conditions. I don't want to check the distance. I just want to get all the perimeter values stored in any primitives available. If I check it, okay, now the perimeter has been copied for each surface. And actually, I do want to have it as a point attribute in the end. So I'm going to promote the copied primitive to a point. Okay. Okay, if I leave the loop, do I get the difference? So, yeah. Yeah, so I do see some different values, so it should be working. Let's just check the surfaces. If anything has 0. Okay, so every surface has some kind of values. It's good. Okay, so let's try using this value as a base for the height for the heart shape. Okay, so where were we? We were trying to set the height of the carving. Now let's attribute promote the parameter that we have just promoted to a detail, the maximum, and let's also get the minimum as well, so that we know the range of this parameter. Okay, so we have now minimum parameter and the maximum parameter stored in the detail. 0. Why do we have 0? Okay. That is coming from the heart, the inner heart shape, which is not a problem, I guess. Yeah. Okay, so now that we have here, now that we have those informations, let me just check this again. Going at the surface, check the perimeter. Okay, okay. Should be good. Now, let's get the minimum perimeter. Max perimeter. And let's try normalizing the current perimeter by remapping it from minimum perimeter to maximum perimeter to 0 to 1. Well, it might not be a 0 to 1, I'm not sure. And then we could decide, based on this information, we could decide how much of a curve height we want for each curves. Now let's say there are several ways to consider how we estimate the height, but maybe the easiest way is to create two height informations. One is minimum height, one is maximum height, and just map this normalized value to minimum and maximum height. Okay, so I'm just going to delete the old one and try to use a fit function for perimeter. So if it's equal to 0, which is close to the inner surface, should choose the minimum height, I guess. If it's close to the outer surface, it should be close to a maximum height because it has more perimeter. Now if I change the face, so I guess we are controlling based on the height based on the edge, the perimeter length, and that looks a little bit better than the old one. If I do this the same value, previously it looks like this, where the inner face seems to have more depths, although the depth wise it's the same, but based on the width it looks deeper. But if I make this smaller, it looks pretty much better. Okay, so overall looks good. Now, so this is one step that I wanted to do. Okay, now the other things that I want to do now is to make the whole inner layers go dig down below the sphere. Currently it's still on top of the sphere. I mean that this layer curve is still on the sphere, but what I would like to create is more of a shape which goes like this. If you look from the side view, or if you look from the side view, I want to try to make something like this, trying to make each layers go deeper down the sphere as well. Current situations is looking like this. The base heart shape is still on top of the sphere like this. So in order to do that, you need additional information which is stored inside a point attribute. In this case it is a curve u value, this one. Previously we did have a curve v, we did use a curve v, but now we want to use this curve u in order to kind of dig down the sphere. Okay, so let's try doing that. So I'll try to write it beforehand. Okay. So, and how do I call this? Dig. Okay, now okay, so what I need to think about is how do we actually map this curve u value. Now there's some maximum values and minimum value for this curve u as well, so let's first of all get the maximum value of this curve u. So I'm going to again create an attribute promote to promote the curve u value from point to detail to max. Don't delete the original. Get the maximum curve u. In this case it's 5 because we have 5 layers. Okay, so let's get that information first. not the, okay, max curve view. All right, then what I need to do next, so this is a bit tricky because this is a bit tricky because let me see. Because so I want to make the spiral curve going gradually going downward. Okay. So and what's the best way to do that? Actually, I might be able to use another curve V for that purpose. I mean, I do have a previous implementation which works, but now I'm thinking if that's the best way or not. Let me just test the way I just think about it right now. Okay, so we have a curve V value, which is going from 0 to 1 from this edge to this edge. Okay, and we also have an information for each layer, in which layer it is. I mean, okay, actually we do not have that information. Let's go back to a for each loop on where we are updating a surface point attribute. I am also going to add a iteration value so that I know in which iterations the surface is being created. Okay. All right. So now that I have it, let's check. Going into a point wrangle. So we have iterations. Okay. And now let's go to the somewhere around here. Okay. And let's try to get that information, which is iterations, and combining this with iteration and the curve V, I might be able to just create a digging parameters instead of using curve view, maybe. Let's comment this out for now. And so for each iterations, it starts from 0, 1, 2, 3, 4. So if you add this value by curve V, you actually get the similar value to curve U, but in a different direction. And actually the maximum value is the same, I think. So maybe I could still use this value here. Now let's calculate the digging height by remapping this current iterations plus curve V, which is from 0 to the max curve V, and make it so that it will be go 1 to 0. So the center, if it's close to the center, just go deeper. And try to move based on this DH. Okay, wait. Got some errors. uninitialized variable dh. Invalid cells, reference to undefined variable max curve v. Oh. Max curve v, curve, oh. Mistake. Oh, wait a minute. This is okay with the max curve u. This has to be max curve u. Okay, so it's moving a lot. That is because this dh is a bit too big. Let's make it smaller. See if it's gonna work. Let's try to move this gradually. See if it's gonna work. Okay, it seems to work. Something I didn't expect it to move. Huh. Interesting. What's happening here? So when it is close to, when it's on the curve position, it just goes really deep. And all the other positions is being gradually changing, and that looks fine. But the positions on the curve area moves a little bit differently. Interesting. Why is that? That might be due to the result of this fuse might have changed the iteration value when being fused. That might be the reason. Let's check. So if that's so, it might be a better idea to create a pre-computed curve u or curve v value together with the iterations. Okay, so it seems like it's 0 on the edge somehow. That might be is because of the fuse, I guess. Let's go before the fuse. Let's check before fusing. Previously, what does it look like? So previously it looks fine. Yeah, the 0 part is just for the curve, so that was fine. And okay, so this fusing is also working on the curve, which that's not necessary, so let's limit the fuse to the surface. First thing first, meaning we also need to have a point group for the surface here. And let's see what happens now. Okay, so became 3. Used to be 3 and 4, but just became 3. And that could also be a problem. Yeah, that's also a problem. So after all, we cannot use iterations, but we kind of need to update the curve v, which is here. Not the update, but create an additional value which also take an account of the iteration value as well. This is the normalized value and it's already been used, so that's fine. But I also need an information which take an account of this iteration value. So let's connect this to here. And this iteration value, I can just delete it. It's a bit confusing. So just delete it. And I'm gonna get the iteration 2 value from the third input. And how do I name this? Let's just call this whole curve V. Okay, which is iteration 2 multiplied by plus curve B, I guess, curve or T. That way this should be gradual, so it's not going to be a problem when you do a fuse, I think. Let's check. Let's check. So it's another marker, whole curve V, whole curve V. Okay, so starting from 0, oops, getting really big here. Well, it starts from 0 on the center, so that's fine. So 0, 0.2, 0.3, 0.4, and what's happening here? Let's move this up. Okay, so it's 1, and this one. It's 1. Okay, so it's continuous. Looks good. All the 0, 1 is coming from the curve, and we don't really need to worry about that one. Okay, so we now have that nice informations. We can now go back to where we were creating a carving value based on the whole curve V. So we know. So instead of promoting the curve U, going to promote the whole curve V. Curve V. Okay. Then just gonna call this max WCV from the first input. Okay, so I can get the normalized value by just dividing the whole curve V by max WCV. The 0 is close to the center, 1 is close to the outer place. Now I could map it to make it as a real offset value. So if it's close to 0, I will set the maximum offset value, the parameter name, dig height, then 0. Okay. And I'm not using a DH anymore, so just delete it. Okay, so it should be like this. Okay, now let's try moving the curve, the parameter, and it looks good. It's moving as I want it. Okay. Looks good. Everything as it should. Okay, so later I could also apply some ramp parameter to control the curve, how it can change based on the positions, how the curve, the section curve of this digging could be changed by a ramp parameter, but for now looks good. Same with this one. Okay, now what I want to do next is to combine this mapped carved surface with the rest of the sphere shape. Okay, so you need to create the Boolean between the sphere and this shape and combine these two together to make as a one continuous shape. And that's what I want to do as a final. Okay, so let's do that. So to do that, yeah, let's go back to where we have mapped the surface, and I'm going to try to create a extrusion out of the surface and try to use that to calculate the Boolean between the sphere and the surface. So let's do that. First thing first, I'm going to offset this surface a little bit to a normal directions by some small numbers like 0.05 or something. Okay, and then I'm going to use a poly extrude, which is using a point existing normal by 0.1, which is the double number of this value. We'll create an extrusion like this, and let's also close the back face as well, like that. And that should be covering the part of the sphere that I want to trim. So let's bring up the sphere and try create a Boolean. Now the Boolean is kind of unstable, so sometimes it fails. So in order to make sure it's fail safety for many purposes, I need some setup for a Boolean. First of all, now I wanted to make sure that it's going to resolve the self intersections, but it's already failing. So, and I wanted to use a subtraction. Yeah, it's good. So I just wanted to do a Boolean between this surface and this extrusions. Now, currently, obviously, it's not working. There seems to be some points created somewhere around here. Not sure what that is. Okay, let's see if I can do anything to fix it. Nope. Not really a chance. So in this case, seems like I need to now this doesn't also work anymore. And this works, and I don't really know the reason why. It's probably due to some small holes like these, which was created where did it create it? Due to some failures of this fusing, maybe. Okay, well, maybe I'll try using this 0.1. Try avoid using the match size at this point. which might be really big. But you could reduce this number to 0.001, 0.001. Okay, and how's that go? How that goes? Now, yeah, it's not working. Wait, whoa, what's happening? So we have this surface matching the size to a disk. Where's the disk? Ah, okay, I think I need to scale it. Okay, it's where is it going? To X. Okay. And each time I press space bar and F, it just rotates like this. How is it? Why is it? I don't get it. It's to a random direction. Is it a bug, or does everybody have some experience with this? Really hate this. Okay, now the surface has been mapped. Okay, I need to create a camera, reset the random rotations. Okay, then check the Boolean. Okay, seems like it's still failing. If I look at this carefully, there seems to be issue on the center. Seems like the mesh is not being fused on the center. These ones. It's not being fused. Maybe. It's not being fused. Oh, after this. It is being fused. Let's check with the poly extrude here. And check with the clip. Okay, some issues here. What's happening? Huh. I guess, okay, so that's because the new point's being created because of the mesh. We've added the new point on the edge with this remesh, so that was the problem. Let's make sure this is bigger than the edge here. Okay, now it looks better. Okay, now going back to Boolean, now it seems working. Okay, for now. Might gonna fail again sometime later, but let's just go with this for now. So we have a Boolean shape. I'm going to triangulate it just in case, and just simply merging these two together. The downside is that the edge is not matching correctly like this. So if you need to match the edge, you need to do some additional steps like remeshing and so on. But for now, just go with this. Okay. And starting to look good. Now let's go back here. And what else do I need? Okay, let's also check the edges. Okay, so there are some problems here where you have some openings. That is because of the carving height that I applied here using the sine wave. Okay. So in order to fix this, you need to make sure that this sine wave is not going to be applied if it's close to the starting edge of the spiral. Okay, till the end it could go as is, but if it's close to the starting end, or maybe the end, maybe to the end as well, you might want to reduce the amount of the sine wave, the carving weight, for the first and end of the spiral curve area. Okay, which can be retrieved by checking the curve U in the end. So we could use curve U after all. Okay, so let's do that. So let's get that information. Let's create some information here. So what we need to do is to modify this curve value based on the curve U. Curve U represents the positions from the first point on the spiral to the end point of the spiral. So we do need a maximum value of this curve U. So let's get that. Max curve U. Okay. Hello, thank you. Okay, so let's get the max curve U. And then normalize the curve U value by a max curve U by dividing it. So now we have a curve U based value from 0 to 1. The 0 means that at the starting point of the spiral, 1 means the spiral end of the spiral, end point of the spiral. Now we could use, so if it's close to 0 or 1, I want to make sure that this curve val is 0. So what I can think of is create another sine wave value applied by using this value as an angle. So let's call this curve mult or carve mult by using sine wave for a curve U multiplied by pi, which gives you a value in between 0 to 1, like a wave, and then multiply directly to this curve value. And now something still weird is happening, but this part is straight, and gradually it's increasing this curveness. Okay, so let's see what's wrong with this part here. Why has not been closed? So if we look at the original surface, okay, And if we check the Boolean shape, and okay, so let me see again. The reason why this happened is because this part is being offsetted using the value cov v beforehand, using this dig value, and that was the issue here, because for the cov v, for the whole cov v, this value is 0 and this cov value is 1, so no matter what, I mean, I wanted to make sure that this part becomes 0 flat, shouldn't move, but because I'm using dig value, it's gradually going down from the outer curve. So what I would suggest doing is to gradually going down, starting from this point. And same for the center, stop at this point. So end point also has some issues like this because of the same reason. So what I think I need to do is to remap by setting some offset. Remap this whole curve V by setting some remapping, setting some offset value by 1 for the starting and the end, so that we can ignore the first layer, the first offset, the first gap, which is from here to here, and for the end, here to here. So to do that, we need to think about using a bit more complex way to remap, normalize the value. So I'm going to use the fit functions for max for whole curve V. And what I'm going to do is to remap from 1 to max WCV minus 1 and make it so that it's going between 0 to 1. Okay, so kind of a trimming the first one from this value. And now it looks a bit more cleaner, and if I look at the final result, there you go. Much better. Alright. So started from the really flat surface, gradually creating an offset. And you could control the speed, how much it changes the curveness, the curveness for this curve multiplication by maybe applying a power functions or ramp parameter. Maybe. Let's just use ramp parameter for ease. So chrump curve mult ramp. So now we have this curve, and I could control the remapping value by a curve. Oops. Wanted to make it smoother. So if you want to start decarving drastically from the starting point, you could do something like this. If you want to slowly start carving from the starting point, you could do like this, and so on. Maybe I would, I don't know, going going gradually like this. It's pretty up to you. I might want to have something like that. So quickly it gives you a carving and gradually slows down on the middle and going again speed up the the depths. Okay, so well, it's pretty up to you. Okay, so we could do the same thing. We could have the similar ramp parameter for all the other values, like the height value, which is applied right here. Okay, which comes from the perimeter right here. So for this perimeter, you could have another parameter. For this perimeter, which will control the carvedness or the curvature of this carving. Okay, let's make this B-spline, and so from the center to the outer, you can control the effectiveness of the carving. For this one, maybe either these or these, maybe these. Looks natural. Okay, and finally the DH, the going deeper one, which is like this, or if you go negative, you can go like this as well, which looks like a cartoonish eye. Okay, and for these value, you could go minimum as well if you'd like, which is again looks fun. In some usage, could be useful. Okay, so let's control this dig height parameter with the ch ramp. So again, I have another ramp parameter, and this one gives you control over the section carve of this digging. Just like that. So just choose whatever you think looks natural, like that, or like that. I don't know, maybe that. Okay, and hopefully this works with multiple number of sections, layers. Yeah. Okay, now if it goes to 10, it's not working anymore. Maybe it's because of the Boolean. This Boolean is really unstable. Gotta think of the better way, I guess. So because we have multiple number of layers, we have small like points here and there that might be creating some issues because of for the Boolean. That's always the reason. So if I clip it, I might see the reason why it's not working. Yeah, maybe not. not so obvious yet. Okay, one thing I could try. I could try polyfill. Nope, didn't work. Clean. Nope. Polydoctor. Nope. Divide. Nope. Okay. 3 hard. So it's not going well. I don't know. I don't know what else I could do here. Let me first copy this value right here to share the snap distance and make this a little bit lower. See if it's gonna work. Nah. Nope. Okay. I am assuming the problem is coming from the parts on the middle, somewhere around here, and should be fine on the edges size. So what about trying remeshing this poly extrude to some value here. It still tries to preserve the edge straightness as much as possible, but yeah, it does have some issues. I mean, what I would want to avoid using remesh because it changes the shape in some respect, so it's not really a good idea, is it? Let's make the smoothing 0, maybe a little bit better, and try using this as a boolean. Now this works. The issue is, what will it look like when it added together? Not bad, maybe. Maybe not on these edges, but that's due to how I created the heart shape. So in order for this one to be fixed, you kind of need to remesh this part corresponding to the outer sphere. So that's another additional steps you need to do if you want to do that. So I'll just skip doing that for now. Overall looks fine. Now let's try visualizing this in a bit prettier manner by applying some materials. I'll just use a matcap material. Create a matcap shaders on mat network and load some pics. I just downloaded some matcap image from the website. I don't think it's copyright protected, so I'm not going to host it, but the image looks like, which one is it? The image looks like these, different name, 3C34 or something. Okay, and try using that to visualize the material. Right, and looks like this. Yeah, not bad. Okay, and without the edges, looks like this. Okay, so there are some smoothings being happening on some edges. It's due to how you define the cusp angles. Or you could predefine the cusp edges using like edge group, I think. You could also do that. That's the easiest solutions. Okay, so this is it, I think. Now we have got the shape that we could control over. We could create a curve, a 2D curve on top of the sphere, mapping it, and create a carving face on top of it from the curved surface, a mapped surface. And by animating those values that I have set on several places, you could create animation that I have shown you previously, which looks like this. Okay, so let's try this. Okay, so let's organize this a little bit. First thing first, I am going to bring all the parameters that I can use to control this setup. Okay, create a null node, and oops, trying to bring up those parameters that I can control. First of all, the curve offset, which define the openness between the endpoint and the start point of the basic closed curve. In this case, a heart shape. How do I name this? Base curve. Not a good name, but let's go with it. Okay, let me just bring this back to the other display. Check what kind of parameters that I have. Okay, well, let's name this shape offset. Okay, now we have another parameters which is to control the scale for mapping, which is controlled by this uniform scale. So let's bring that and call this shape scale, and let's make the maximum to, I don't know, 0.5 or something, or well, I don't know what could be the maximum here. Let's check. So it should not go above 1. 0.8 is already too big, or maybe you could go, so maybe 0.7 could be the maximum for this setup. So let's say 0.7. Okay, we have number of layers can be controlled here. Okay, we could control the carving. We have several here. One is the carving minimum height and maximum height. So actually this is not a minimum, but it's based on the closeness to the center or outer line. Realized. So let's see. If I change the minimum, if I change the maximum, okay, so this value is effective close to the center. This value is effective close to the outer. So center height. And for this one, out height. Okay. And the height. Digging height. Okay, then we have a bunch of ramps, corresponding ramps. So for the carving, we have this carving height ramp as well as carve mult ramp. Which is not easy to imagine from the word. I'm really bad at namings, but yeah, hopefully you could imagine. And we have a digging height ramp. Height ramp. Okay. Okay. What else? What else? Oop. Got errors. No. Okay. Hopefully I get some crash logs or temporary files being saved, just been crashed. Okay, and it's not closing. Okay, what else should I do? Well, yeah, I should try creating an animation. Okay, hopefully I'll be able to retrieve the crash files. Cross fingers and go. No backup. Oh, really? That's because I force quit the file, maybe? Well. Let's check the crash directory. Let me just check the crash directory manually and see if I can have a crash file. Okay, nothing. No, nada. Oh well. I do not remember if I saved it during the process. Okay, so this one, 1:13, so 7 minutes ago. Not that bad, I guess. But I do not have a controller. Damn it. And how far did I go? Well, at least I have a material, so I should have all the parameters being ready. Just need to redo the parameter Mapping. Damn it. Okay. Or do I have any autosave file? Let me just check. Backup file. Spiral carving. The last one is... no. 7 minutes ago, so the same. Okay. All that happens. One lessons learned. Even if it's not responding, you might need to wait until you get the crash file. Do not force quit. Okay, I'll just skip explaining, I'll just do it fast. So we have here, shape offset, we have scaling, shape scale, 0 to 0.7, and layers, number of layers. Okay, what else? Carving, minimum height, maximum height, dig height, a carve ramp, carve height, ramp, dig height, ramp. Okay, and let's rename this. Height ramp, carve mult ramp, carve mult ramp. Dig height ramp, dig height ramp, dig height, dig height. Now this should not be too big, so 0.2 maximum. Maximum height. Maximum height. This was carve out height. Height. Again, this should not be really big. Carve center height. Carve center height. Okay. Right. Okay, let's save it. Okay, I think this is all we have in order to control the shape. Possibly. Let's try. First of all, the most drastic things you could do to change the shape is changing the scale. Just like that. So just by animating this would be really interesting. Starting from the small shape, gradually wrapping the sphere, and in the end you would see another heart-shaped spin appeared on the back side, which is pretty interesting, isn't it? How's that for, I don't know, Valentine gift? Or Christmas ornament or something. Right, looks good. And shape offset, you could change the scale of the starting point, and you could change the scaleness between each curves, you can control the size of the holes, the relation between these curves and the size of the holes, which is good, also interesting, right? You could this could also be animated to make it interesting. And obviously the layers, the number of layers, It's pretty obvious. Okay. And the carve center height, the height of this carving from the center. So if you make this smaller, you have flat carve on the center, but you have more carvings on the outer layer. If you make this one 0, you have flat carving. On the outer layers, you have more carvings on the inner carvings, inner layers. So you can control however you want, like this. Okay, and you could also use this ramp parameter to control the carvedness based on just remapping the sine function to whichever you want, more flatty or more carvy, so on. If it's linear, you're just using the same sine functions as is. So if that's fine, that's fine. And then another ramp parameter is a carve mult ramp. This is controlling the rampness from the starting point of the whole spiral curve to the end, which controls the flatness. So if it's flat, if it's 0, maybe you should make it 0 like this as well. This is fine. If it's and you just remapping again the sine functions. So consider 0 means 0. I mean, so you're just remapping the sine functions. So you're using the ramp parameter. So if you look at the ramp parameter somewhere around here, you are remapping the value here and here. If you're remapping the value, if you're looking at this parameters on the ramp, you're remapping the sine value right here and so on. If it's here, here, and here, based on the y value. And I just realized that the image is flipped. Okay, anyway. And yeah, so by controlling these part, you could control the effectiveness of the edges. If you raise this up more than 0, you're going to have some openness, so that might be a problem. So you might always want to keep this value 0, and you might also want to keep this value 1 for this. Other than that, do whatever you like. Maybe something like this is looking good. Yeah, not bad. Okay. And what else? Dig height. So this will control how much it will go down. The center part, how much the center part goes down. Now maybe I could increase the maximum value here to 1. There. So this one is drastically going down, just the center part. So if you want to go linear, you could go like that. And you're going to see some drastic digging effect happening. And this could be interesting. Yeah. It might also be a great idea to animate this as well. Like from 0 to V to something like that. Alright. Hello. Are you using Python language in Houdini? Yes, I do use Python in some cases, especially if I want to communicate with other files, like text files or CSV or other formats. I do need to use Python as a scripting language because it's more versatile than Vex. But most of the time, if I just need a vector operations on points or geometrical operations for geometries, I would rather use Vex because it's much faster because it works on multi-thread, I guess. I think that's what I understood Vex as is. It's much faster than Python, I think. So everything looks ready. Now let's also try to use other types of curves. Currently I am using heart shape as a base, but could be anything if it's closed curve. So let's try with the simple curve like circle. Already have a circle here, so let's try switching between the base heart and the circle. Now the size looks a bit drastically different, and this is an open arc, but I don't see any changes here. So this is the starting point here for the circle. Okay, the curve offset has to be done for every curve. Okay, now, so the offset looks like this on the circle. Okay, since the base size is different, yeah, since the base size is different, it might be better if you set the size of the circle similar to the heart so that you could use a similar value for different shape. So I'm gonna use a match size to set the size of the circle close to a heart shape. Don't do the translation. Okay, so now it's similar to the heart shape. Okay, now you have this spiral offset. First layer of the circle and go down to the end. Let's see if it's gonna work. No, it's not working, and let's see why. And here I do see a layers, maybe in a different order. Yeah, the up vector is kind of reversed, so that might be the reason why it didn't work. Let's check the surface. Okay, so if I switch to the heart, okay, so let's try reversing the circle curve. And now it got smaller, but it didn't fix the face direction, so this might not be the reason. Okay, so if I have an offset curve resample, if I look at the resample, yeah, starting from 0, it's fine. Okay, and going into all the stuff here till here, it looks fine. Did it map to, okay, this part looks weird. Sphere mapping might be correct. Carving, do we see it? No. Okay, it's not mapped, I think. Or is it? It is mapped, but when you add it, okay, so Boolean is not working, I guess. So this thing is being used to trim the sphere. That is because this is the normal direction is upside down. That's the reason. So it's going back to this process. The reason why it didn't work is because of the face direction. Okay, so what's so different between this one and this one? So if I do the reverse, I think I should also resort the point number based on the vertex order. Okay, now it works. Okay, now let's get to the result. Let's get to the result. See what happens. All right, thinks it works. Now see some what is this? It's not as it's not I supposed to get as a result. Something is wrong here. Then there shouldn't be any like dynamic or drastic change on the edge, like a crack like this. So something is really wrong here. Okay, might be missing something. Let's switch to a heart shape. So this one looks okay, right? But this one, no, it's not. Okay, let's check this out. Going to a carving. Okay, so from here, this is already wrong. Surface. Surface wise, it doesn't look wrong, but yeah, it's all being connected. Let's check the curve U or whole curve V, which looks okay. And where was the problem? This, somewhere around here. So this part, it's not smoothing. Okay, so right, I see some problems here. First of all, let's gradually make this value 0. Okay, so if I make this value 0, it looks fine. So problem might be coming from the dig height. So this now looks fine. And it's based on the spiral. Let's make the scale a little bit smaller so it's easier to see. Shape, make the layer smaller. Okay, and if I increase the dig height, okay, starting to see some issues here. So probably I was having the same issues on the heart, but I really didn't see it because if I was on the ridge, maybe this is where the error was happening. and now I could clearly see the problem with this dig height. Okay, so I need to fix this. Good that I noticed. Okay, in that case, I need to use some smoother value, which shouldn't rely on curve v, but after all, curve u. Yeah. You should add Python language in stream, make some stuff basic if possible. Well, if anybody is interested, that would be an option for sure. I don't know if the basics is fun to watch. That's my only concern. Okay, so let's go back to the carving. And this is what I need to fix. Okay. And to fix it, I was previously using a whole carve v, but that was the problem because it wasn't continuous between this face and this face, or this point to this point. It was some jumps by one. So to use more natural value, you should use curve u, I think, instead. And for the curve u, you have more smoother value, like this. So let's use that, shall we? And okay. So for the curve u, I think I could just let me think. The curve u, we have two types of curve u, one for the inner curve, one for the outer curve, and each one has different value, right? So let's see. What if I just replace this to a curve u? Would that fix it? And I can just reuse this one for the max one. Okay. Now, if I apply it, oops, something is not right. Okay, now, so the curve u starts from here, which is 0, I think. Yeah. Then going to 1, going over 1 like that, and remapping by dh. So I think this was correct, but it's not. Curve e. It should be curve u. Oh, nope. Wait, curve u. Okay. Okay, looks better. Some not good. Something not good yet. Yeah. that's the difference between the outer curve and the inner curve, I guess. Okay, so in order to fix that, let me see. Yeah, first of all, you need to calculate two types of curve u value, I think. So one is the inner curve, which mapping the curve u from 1 to max curve u, and that's the that's the inner curve, that's the outer curve. Well, let's normalize this first, and I have another curve u which remaps from 0 to max curve u minus 1. That's for the outer curve, if the first one is the inner curve. So we have two curves, they create a layer, right? And then we could then have a final u value by lerping the u1 and u2 using the curve v. And finally, I can just remap this u value with dh, or just multiply u by dh. Apply. Still doesn't look correct. Still it's not correct. Maybe I have... Wait, where'd it go? Where did the update go? It just disappeared? How come? So we have max curve u. I don't understand. Where did it go? So fit f curve u, which is from 1 to max curve u. I think I should do 1 to 0 for this. u2 fit f curve u from 0 to max curve u minus 1 to 0. Okay, and then replace dh with u. Okay, and I got errors. That is because forgot to create a u. U is lerp between L1, U1, U2 with curve V. Okay, not in, maybe the other way around. Nope. I think I have to say max curve u minus max curve u minus, make this 0, 1, 0, 1, and apply. Okay, still have some mistake here. First of all, need to check if name convention is correct. Curve U, max curve U, U. Yeah, looks correct. H. So let's for now just remove these flat. Okay, so obviously the center should be moving instead of the outer curve, so the other way around. And the reason why is because is the curve U starts from 0, right? And that should be equal to 1. So curve U, and if it's close to 0, you want to move farther, just like this as well. Okay, and what if I just choose U1? It's not changing much. Okay, so the issue is here. The remapping is wrong. So curve U, do I have that first thing? Curve U, yeah, I do. And want to make sure the curve U, the center part have the smaller value. Curve U. Yeah, so these values on the center smaller. If it goes outer, you're going to have bigger values, so that's fine. Max curve U from the detail 5, okay. So from 0 to curve U, so 0 to 4 something. Going to remap by 1 to 0. Right, then you are mapping it with the digiheight ramp, which is just a small modification to the linear value, so that's also fine. And this is what is wrong here. This should be 0 to height, so that was the place I needed to fix. Okay, now to fix the ridge I need to use U, and now you should be able to have a cleaner edge. What's this? What's happening here? But overall looks good. What's this here? Okay, something is still not wrong, not right. Probably this is due to the value difference for U1 and U2, I guess. Should I make it U1 and U2? Oh yeah, that was the reason. Okay. Finally, I think this should work. Well, maybe not yet. Huh. Okay, let's check this U value, how it does look like. If it's not continuous value, then that's the problem, that's the issue. So yeah, it's close, but it's not so continuous. I think that's the reason. Okay. Just needed to make this just need to make this continuous. And why it's not working? The place where I'm creating a curve view is right here, right? Okay, curve view. And each point has its own different value here. I mean, based on the position. Like this. Okay, and on the next layer you have a value +1 to these value. So overall, these part should be the same, and if I look back at the carving, if I check just the curve view, okay, so these value is the same, and there is a point where it drastically changes. No, I mean this is continuous. This is continuous, so that's fine. It's fine, but drastically changes by changing the layer. So where it says 2, it becomes 3 in the next layer. So this is where we need a smooth interpolation. And if I choose U1, just visualize U. If I choose U1, so it looks like this. If I use to U2, okay. So U1, let's just check somewhere over here. If I want to have a smoother connection between this layer and this layer, this is a value U1, this is a value U2. Okay, so so U2 is lower, U1 is larger. Okay, so that means I think I want to LARP between U2 and U1. To make a U value. And if I visualize this, no, that was wrong. It's not correct. Okay. Let me think again. I have to subtract this by max curve view after all. Okay, now I think I have smoother values continuing from center to outer, like this. Okay, it's better. Is it? Let me just check. So 0 to 2, yeah. 0.24, 0.5 to 0.7 and so on. Okay, looks good. Yeah. And now I'm using U value to move. I should be using U value, right? To move the point, and hopefully this is smoother. But somehow there's some gaps here. Still not sure why. So seems like there is a little gap between, well, not so much. I mean, it's pretty, this value and this value is pretty much the same. Close enough. Doesn't look like a big difference, say. So what if I multiply this by 0? Okay, now it looks fine. So probably this carve val also has some issues here. So if I increase the DH, oops. Now what's wrong? Okay, now I think I need to make this reset back to this. Okay, so for digi height, it's okay. Now the issue was still exist on this carve val. So let's fix that as well. Okay, so this was, and I think the issue is coming from the same curve U value, which is this one, using this one for the sine curve. So instead of using the curve U, like just going to use a U. No, didn't fix. I think this will be the problem if I make it 1. No, wasn't the problem. No, it was not the problem. So if that's the case, then curve V is the problem, is it? Or perimeter? Oh yeah, the perimeter, yes. Since the perimeter for each layer set is different, that's the reason. Right. I should not have used the perimeter after all. Okay. Yeah, makes sense. Yeah, I should not use perimeter. If I remove this, I think it should work. Although this is relying on the perimeter, so okay, so what shall we do? Instead of using perimeter, what can we do? I mean, instead of perimeter, I could just use curve U or curve U, or this U value, I think. Yeah, I think we could just use that. Let's try using curve U instead of perimeter, so that it doesn't really matter how the length is, but you're just counting from center to outer. Yeah, I think that would work. So stop using perimeter. So instead of using perimeter, you going to use the ramp for curve U. I'm gonna just use the same variable name, but instead of using Peri, using curve view to remap. There you go. There you go. It's been fixed. And I think this part is fine. I think in terms of the shape, looks gonna look like this. Okay, finally. Doesn't look clean. Let me change the value, see if I can. Okay, overall looks good. What's happening here? So the curve is flat here. Probably due to the remapped surface. Nope. This one? Okay. So it kind of a remapped in not really good position somehow. And this point position is kind of relied on all those curve U and curve V value. So let's check that value, how it look like. So this is curve V, curve U. So if you look at those values, I can see that so red one is the curve V. Curve V might not be affecting much, but curve U, I think you're supposed to have a bigger value somewhere around here, which I don't see the value here. So that might be the reason. Okay, so probably it's due to a failure of transferring the attributes from one side to the other. So I'm not sure if I can fix that. It's a bit hard. I could try by transferring the attributes to the small center. Just the point curve U, curve V, and yeah, looks better. Yeah, maybe that fixed it. Perimeter, I'm not using perimeter anymore. SC, curve, whole curve V. Okay, so yeah, better. Okay, that took a while to fix. Now if I change this back to a heart shape, hopefully it still works. Yep. Okay. And okay, still works. Let me just test with one additional shape like star shape, and if it's going to work with that, then I think it's good to go. And I'll finish this live stream. And let's try that. Okay, so in order to create a star shape, I could go from circle probably. Resample the curve, resample the circle to a number of points, like using a even number. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And based on the even or odd number, change the point scale to smaller size. Something like that. Okay, so this looks like a shuriken, so maybe something like that. Okay, so make a quick star shape like this, and let's have enough points for high res setup. Yeah, I think this is good enough. Okay, and also resize it just a bit. Okay, and try with this star shape as well. See if it's gonna work. So first of all, if I offset it, looks like this, and create the surface, looks like this, map it onto the surface, and looks like this. Good. Great. Looking great. And does it going to work? Yeah, shape offset, scale. How's that for I don't know, some superhero thing badge, I think. Nice, more like a flower shape. If I increase the edges more, maybe it would look like a flower. Yeah. Maybe not. Okay. Get it. Yeah, this is better. Okay. And all the other stuff, you could try animating it. Make some interesting animations. Change bunch of parameters to test out all those different shapes. And so on. Okay, let's have this switch as additional parameters and I'll finish this live stream. Could be interesting as a lampshade maybe. Okay, this is it. Thank you very much for watching, and let me know if you have any feedback, how you thought about the steps, comments or anything. I'd love to hear it. Yeah, seems it's like working. Still see some issues here. When there's a difference between curve center height and curve out height. That's not good. Okay. I think I need to fix this. Everything else is fine, but this part, not good. Not good. Why is this happening? That is because of the same reason, I think. using car view for here. So instead of using wait, why it's the update's been deleted? Oh my, how come? How, why I don't get it. I do not get it. Okay, now it's been fixed. Phew. Okay, so that was some errors happened. The update's being, I don't know, reversed for some reason. I don't know what happened, but now it should be okay. Okay, cool. All right, so I guess I don't see any questions. I'll just finish this live stream here. Okay, thank you for watching, and thanks for all the comments. It motivates me. After doing the live stream, after finishing the live stream, I will upload the files that I've created on live, and you can download the files from the description page of this YouTube live stream, so you can come back to the same page to download the files to test out yourself later. And I also have a Patreon page, so if you're willing to donate, that would also be great. Okay, that's it. Thank you very much, and I'll see you tomorrow. I'll see you next week and around the same time. Okay, thank you and good night. The end. I'm gonna end this stream.